Good morning, everyone. I'm Yu Chen. Today, we will discuss the projections of the unemployment rates and the number of new cases in the UK, Singapore, US, and the whole world. At this stage, it's urgent to do predictive analysis for COVID-19 as it allows us to estimate the pandemic's behaviors within an acceptable degree of uncertainty by establishing when and under what conditions a country expects decrease or increase in their rates and the number of new cases. We will then briefly discuss the data we grabbed, the model we used, and the results compared with observations. This next slide offers a quick overview of the data and the methodology we used. I hand it to Liang Shimao, who was responsible for the raw data.
The first is our main data set, which was provided by Professor. Other four data sets are all exogenous variables. In terms of unemployment rates, number of workers applied for unemployment benefits is used as exogenous variable for US and UK, as it directly reflected how many people were unemployed. However, the statistic is not available for Singapore, and we chose concentration of nitrogen dioxide. This index was closely related to industrial emissions, which in turn indicates industrial activity. Research has shown that the lower the concentration, the fewer the industrial activities, which may also indicate that the unemployment rates would increase. In terms of new cases, the index of driving movements via Johor-Singapore Causeway was used as an exogenous variable. The reason behind was that Singapore has been reopened to the world in August, and this causeway is one of the main paths to enter Singapore. This inference can be verified by the obvious co-movements of number of new cases and the index. Additionally, government control was also considered exogenous, and Zhang Jiankai will explain a bit more about it in the next methodology part. So these are basically our intuitions behind which variables were considered as exogenous. Next, Wang Chen and Zhang Jiankai will follow me to deliver the detailed part of this model.
We expanded from ARMAX-GARCHX model, which was frequently mentioned in this module, to ARMAX-GARCHX model. Using ARMAX, we predicted unemployment rate and the number of new cases, not just on their own past values, but also on exogenous variables. GARCHX family was considered as the data related to COVID-19 pandemic were more likely to be heterogeneity. Here, new cases and unemployment rates are denoted as YT, and the other exogenous variables mentioned earlier are XT.
I will start with predictive analysis regarding the number of new cases in Singapore. From this figure, since the number of new cases with or without government control corresponded to two distinct stages, for example, increasing or decreasing to be stable, we added whether the government intervened COVID-19 as another variable. Because control usually goes into effect after a period of time, we assumed here the government control had an impact on COVID-19 36 days later. Afterwards, we constructed two models. Model 1 is the common model using all data in the training datasets. Its exogenous variables are whether the government control is effective, Asian cases 115 days ago, and driving movement index 75 days ago. Model 2 is trained by the data without effective government control. We put Asian cases 10 days ago and the driving movement index 75 days ago into the model, but they were not significant. Finally, we combined the predictions from the refined model 1 and 2 to obtain the total number. Note that to avoid using future data, we assume that the driving movement index stayed at the same level after May the 31st, 2021. We also assume that on August the 8th, 2021, Singapore was reopened to the world. In this case, we only use the data before May the 31st to do the prediction. Besides, all the above parameters were adjusted according to the validation set, and this figure shows the best.
projections for the UK and US follow the same logic as Singapore, but took into account their corresponding national cases. But when predicted US new cases, we used containment health index provided by professor instead of government control, as COVID-19 in US world would not be better, ever even if there had been government control. It was unmeaningful. Regarding unemployment rate, as previously mentioned by Liang Shimao, the number of unemployment benefit applications was considered exogenous for both UK and US, whilst the NO2 concentration was considered exogenous for Singapore and UK. Apart from those external variables, our predicted number of new cases was also exogenous for Singapore and UK. Using the auto-ARMA function, we followed the suggestion from R and obtained the final result. The AR, MA, and the difference orders advised by R are shown on this slide. Next, Adina will go through the projection results with us.
Thank you. The following slides illustrates our forecasts. For the number of new cases, we did quite a good job on complying with the actual trend for Singapore. From the graph, it's shown that our prediction has agreed co-movement with observations, especially after the country was reopened, which implies government control was the key exogenous variable. It's also obvious that the stable part and increasing part coincide with the observation nicely at both of the key points. In the next slide, while for the US and UK, also the zigzag part cannot be accurately illustrated by our projections, the basic increase in trends are still consistent with observations. Here we assume that the US, UK, and Singapore share the same driving movement index, and it's a pretty good indicator of the number of new cases. Now we move to unemployment rates. In the next slide, the table on the left side shows the monthly unemployment rate we forecasted. In the graph for Singapore, also there was a peak in October's prediction. The graph still illustrated the same decreasing trend as observation for the validation period. This may be due to the unstableness of the number of new cases that popped up in October, which was the exogenous variable for unemployment rate. The 0.5% decrease in total over 5 consecutive months implies that the US, UK gradually recovered from the impact of COVID-19. In the next slide, Figure 7 shows forecasted global new case plot compared with the observed values, and Figure 8 is the global unemployment rate plot. In the next slide, this is our brief discussions about the predictive analysis. So as it was said before, we use unique exogenous variables, and two-stage model showed a good fit for Singapore's case. Now, Yujia Chen will do the conclusion.
Thank you. It is understandable that projection may increase or decrease depending on our assumptions, but they're not easy to make. For example, even if we chose ARMAX-GARCHX by adding exogenous variables, we were not sure whether these variables fully accommodate COVID-19 shifting trends. More importantly, new variants such as Delta brought its own set of unknowns related to its faster replication and ability to infect. Even if we settle those questions, there is potential for a new variant to throw any long-term computations off. To conclude, uncertainty is a huge challenge to us, but if we could explore more deeply into modeling, we hope that in the future, COVID-19 indexes can be predicted more accurately. Thank you for your attention.